Hello everyone, my name is Kundan Sarma and today I am here to do numericals on principle of momentum of chapter 2 for physics 221 class. And in the question we are given the situation of crash test in which the truck collides against the wall. The mass of the truck is 2500 kilograms and it was initially running at the speed of 24 meter per second, and after the collision the front end crumbles such that the truck is now 0.72 meters shorter than before. So we are asked a multiple of questions. The first question is, what is the deceleration of the truck during the collision? That is, we need to find the deceleration from the interval between the first contact with the wall and coming to stop. So here we know that the distance traveled by truck between the first contact with the wall and coming to stop is the total length of the truck that decreased during the collision, which is 0.72 meters. So we can say that distance as is 0.72 meters, and using the equation of motion we can write v square is equals to u square plus 2as. Since the truck comes at rest after the collision, v square would be 0, u square would be 24 square plus 2, as would be 0.72. We get the value of a to be minus 400 meter per second square. Therefore, the truck is decelerating and its value is minus 400 meter per second square. And the second question is about how long does the collision last. We know that from the fundamental principle of momentum, we can say that delta p, which is the change in momentum, equals to F, which is the net force, times del t, change in time. Here del t is the time of contact between the truck and the wall. This is the value we want to find. So delta p would be p2 minus p1 equals to F would be m dot a dot delta t. So since the truck is at the rest after the collision, final momentum would be 0 and initial momentum would be mass times initial velocity, and this would be same as m dot a dot delta t. We find the value of delta t to be minus u by a. U is the value of u is 24, so it would be minus 24 over value of a is minus 400. So we find delta t to be 0.06 seconds. Therefore, the time of contact between the truck and the wall during the collision was 0.06 seconds. And the third question is, what is the magnitude of the average force exerted by the wall on the truck during the collision? From Newton's third law, we know that action force is equals to reaction force. So in this case, force exerted by wall on truck would be equal to force exerted by truck on wall. Since the force exerted by wall on truck is in opposite direction than the force exerted by truck on wall, we keep negative sign and it would be mass times acceleration. And since acceleration is negative, we get the end result to be positive. So mass is 2500 kilograms and acceleration would be 400. So when we multiply this, we get this to be 1 million Newton. So the force exerted by wall on the truck was 1 million Newton. The fourth and the final question is, calculate the ratio of the force of the wall to the gravitational force mg on the truck. Here we know that the force exerted on the truck by the wall, let's assume that to be F1, is equals to 1 million Newton. We get that from question number C. And the gravitational force, let's assume that to be F2, is equals to mg, that is equals to mass would be 2500 and acceleration due to gravity is 9.8. We get that to be 24,500 Newton. Now to find the ratio, we do F1 over F2, and that would be 1 million over 24,500. We get the value to be 40.82. Here the force exerted by wall on car is almost 41 times more than the gravitational force. Hence, this large ratio shows us why collision can be so damaging. Thank you, that's all for today.